We're going to give you a short report on what we think is a pretty exciting new technology for open source planning tools based on a new generation of Wiki, which is part of a pretty exciting advance in the capability of wikis more generally. It's early days, and I think it's fair to say this is a collaborative technology, so we're certainly interested in discussing this with a number of you and discussing how this work could be taken forward with potential partners. Ward Cunningham, who's with me today, is best known as the originator of Wiki, but it's fair to say that he's one of the leading pioneers of pattern languages in software and in agile methodology and in extreme programming. I'm Michael Mahaffey. I'm the collaborator with Ward, pleased to be collaborating with him. I'm a planner and urban designer with a particular interest in scenario modeling planning tools, scenario planning tools, and in making these tools more useful ways of achieving a new generation of much more resource efficient, high quality development. We're working through a small NGO that hosts research and development of these kinds of projects that was formed in 2007 as part of the Hurricane Katrina planning for the Unified New Orleans Plan. And it was clear to us then that people needed very localized peer-to-peer planning tools, neighborhood scale planning tools, and our NGO was created to take forward a pilot project in that. And it was really about how to use wiki-based tools as a local planning and capacity building kind of resource. And that's really the work that we've done since to develop this kind of bottom-up tool using wikis and pattern languages and other generative open source kinds of tools. I'm personally very excited to be able to work with Ward on this new Federated Wiki, which will explain the structure a little bit, but the headline is I think it has some important new capabilities. It's open source, it's a peer-to-peer resource, it has those advantages. It's able to handle quantitative data, which is an important point we'll come back to. There's transparency of data where you can click through and see the source, the references for the in the peer-reviewed research. It's not the sort of black box problem that many models have. There's an ease of modeling in a relational kind of way where you can move the elements around. We'll show you a little example of that and do that in real time with clients or even members of the public. And then it's a federated structure, which we'll explain, Ward will explain a little bit about that also, which allows people to work on the whole modeling system and evolve it and refine it and then share again so that the whole system becomes much smarter and more capable.
This is work I started a couple of years ago when I was sponsored by Nike here in Portland in their Sustainable Business and Innovation Group to help them share material sustainability data in an open data way. We met with a number of people there and ultimately decided that the spreadsheets weren't going to do it. That's what they'd been using up to then, but they were judged too hard to modify and too hard to understand. So I took the data off the spreadsheets and put it into a wiki that I had been talking about building for a number of years, but finally got around to build. Here we can see a couple of different kinds of data sets, and ultimately the data is kind of reduced to a thumbnail. You can open it up and get into the data, but more likely you want to pull together various visualizations. And this is kind of mix and match. It's all small, narrow pages that would fit nicely on a phone, but if you pull up a visualization, it looks to the neighboring page to get the data. An important part of this was that people would want to make comparisons, and in fact the comparisons could come from different sites. This is where the federation works. Here I've drawn a couple of different things where data from different pages, even different sites. Notice that the little icon associated with these different pages are indicators from different sites, but it still comes together because this all happens in the browser. The browser is programmed to fetch content from other sites and display it.
And as Ward is describing, these are individual wiki pages that are grouped together in it could be used on a handheld, but it's also in a desktop format like this. They can be seen together and they work interactively with each other. So that's what I found very exciting about this from a modeling point of view, that you can actually bring elements together. In this case, these are elements of an urban planning scenario where you've got single-family detached homes, and then you decide to attach some of those homes, and then you decide to take strategies to reduce embodied energy, for example, or do other things. And what you'll see here that's interesting is that the data actually interacts from page to page, so that as you go to the next page, you can see the delta essentially to that value. This is actually written in JSON, and the values are actually calculated again based on the peer-reviewed research showing what the predicted change is under that scenario or under that element of the scenario. And there are a number of other things that you can vary. For example, you notice the ability to do graduated percentages. You can show calibrations of average elements, and really see very quickly, going from page to page and moving them around, what scenario might be the most attractive. Again, because it's a web-based resource, you can actually do that in a way that you can share with others. So if your team or your project figures out a new way to take advantage of the optimum, that can be shared with other teams.
So at the core of this, and this goes all the way back to the founding of Wiki, was the modularity that comes from the pattern language. This was Chris Alexander's work and many others. His form was based on a book, and that book is actually kind of trapped those patterns in a copyrighted work. So we're very interested in seeing the next generation of patterns, first of all, be more quantitative, but also be distributed in a totally open way, so that work built on it can continue to be used and improved.
And Ward, this is something that I think is really exciting about this work, and something that a lot of people don't realize is how much Alexander's work contributed to this, what you've been involved in for many years in software, the pattern language programming technology. But also, Wiki itself was developed.
Absolutely, Wiki was created to support the development of patterns of software development, but patterns nonetheless, and they share a lot in common.
Ironic. And so, what excites me is the idea that we can actually sort of come full circle and bring some of the great innovations of open source technology and federated technology back to the built environment. There's one other important aspect of this. We all talk about externalities in planning, the things that don't get covered in the economic assessments, and the need to recognize those externalities and monetize them so that the true cost of development is paid for, whether it's the negative impacts of development or the positive impacts, the benefits. And so one of the key challenges we have is to find the information that can transmit that knowledge that people can act on. They can actually recognize when one scenario is emitting more carbon or another scenario is costing more in terms of infrastructure cost. And these are things that, once they're identified, can in principle be monetized much more easily. You can have credits and offsets and tax structure based on that, and a whole series of other things. But it has to start with the knowledge of what the impact actually is, and you need the predictive model to do that. So that's where, of course, where scenario modeling comes in, and where this seems pretty exciting to be able to create this capability through a very flexible, extended Wiki resource. So as I said before, it's early days in this technology, but I hope we've given you just a taste of how exciting it is, at least to me certainly, to be working with Ward and to have a new generation of Wiki that's able to handle data, able to be part of a modeling system, a scenario modeling system that's very user-friendly, that's web-based, that communities can use pretty effectively, and that's a very exciting and powerful idea, I think.
And I want to mention that the underlying technology, the Federated Wiki, has been open source since day one. It's also discussed frequently on the internet. Federated Wiki searches well, and you'll find both the GitHub repository with all the code and a series of short videos that I've made early in the development, and so you can watch this technology emerge over a year and a half.
We'd love to get you involved. Thanks for watching.
Thank you.